Hey guys, just in case you missed today's Zoom, we learned about the 8-man strategy. And you need to utilize your periodic table when doing the 8-man strategy. All right? If you go into your modules under 8th grade science resources, it is there, a copy is there, or you can also use the periodic table app in your self serve. All right? So, today again, we talked about the strategy 8-man, and I know you're like, 8-man, what is that? All right? So, we previously talked about the three subatomic particles protons, neutrons, and electrons. Now we're going to talk about how we can actually find the protons, neutrons, and electrons of an element. All right? So if you take a look at 8-man, the 8 stands for, the A in 8 stands for atomic number, P is for protons, E is for electrons. All right? So if you take a look at our periodic table, your atomic number is at the top. We have the chemical symbol, the atomic mass, and then the actual name of the element. That may vary based on the periodic table you are using, but it should still be the same. All right? So if I'm looking for a particular atomic number, it's at the top. So that means the atomic number is going to be equal to the number of protons, which is going to be equal to the electrons. So that means all three of those numbers should be the same. All right? Now, if we take a look at the man number, you see the M stands for mass number, the A is atomic number, and then subtract and you get your neutrons. So that tells us how to find our protons, electrons, and our neutrons. So if you don't know what a mass number is, let me show you. On your trusty periodic table, you're going to see the atomic mass, not the mass number. But in order to change the atomic number to mass number, we have to round. So anytime you have an atomic mass that has 5 or greater, you're going to round up. So for example, if I have 21.5, the mass number becomes 22. Let's say I have 21.05, then that means the mass number is going to stay at 21. All right, so we round up, we never round down. It's either going to stay the same or it's going to increase. All right, so I've provided an example of up here of this particular element here that we're going to discuss how we found the protons, electrons, and neutrons for fluorine. All right, so if you come to your trusted periodic table and you take a look at fluorine, here's our atomic number, here's the atomic mass for fluorine. So we're going to input that number inside of our 8-man strategy. So A, the atomic number is 9. So if my atomic number is 9, that means my protons are also 9, which means my electrons are also 9. So anytime you have your protons and electrons, they should always be the same number. Because protons determines an element's identity, that's why the atomic number is going to be the same as the protons. And then the electrons are still going to be the same. So again, remember, if you have an atomic number of 9, your protons will be 9 and your electrons will also be 9. All right? Now, if we come down to the man portion, remember our mass number for fluorine was 18.998. So remember, the number behind the decimal is greater than 5, so we're going to round up. So that's how we got 19. Now we use the same atomic number we had, which is 9, and we have to subtract. So if you utilize your calculator, because we can do so in 8th grade, it is going to be 19 minus 9. So the neutrons are going to be 10. So if we need to find the number of subatomic particles found in fluorine, we know the protons would be 9, electrons would also be 9, but the neutrons are going to be 10 because we use the 8-man strategy. So we'll be practicing on different elements how to find their protons, electrons, and neutrons using, you guessed it, the 8-man strategy.